Hello again. Before you move on, I would really appreciate you watching the review of trigonometry. It's only a 6-minute video, but in this video I talk about all the things that I will be casually mentioning here and there whenever I do trigonometry. So the sooner you watch it, the sooner you will be able to understand everything that I will refer to later on in this class. I think it's a good video. I think it's a good overview. It's really dense and really short, so you may still have some questions after you watch it. Please do not hesitate to reach out. What I'm going to do next, I'm going to show you how to use, A, how to use technology, B, how to be efficient with trigonometric tasks on the homework and the quiz, and whenever we need it when we do calculus later in the class. So let's go ahead and do some homework, and I'm going to click on next, and the first one is graphing trigonometric functions, and graphing trigonometric functions could be really annoying if you don't understand the actual process and the fact that graphing trigonometric functions is just like graphing linear transformations, and it's just like the way you learned it in pre-calculus class. So that's the most important thing for you to understand. So for example, looking at this equation, all I'm seeing is I see plus pi, which corresponds to the shift to the left by negative pi. So I mean, shift by negative pi, it's the same as shift to the left by pi. And 2 corresponds to the vertical stretch by a factor of 2. That's all I see. And all of those transformations we perform on the function cosine, which is conveniently given to you right over here. So vertical, and we usually do just like the order of operations, we'll do multiplication or stretches, compressions first, and then we'll do addition or translations next. So in this case, I'm going to stretch it by a factor of 2. There you go. And I'm going to shift it by pi units to the left. And that's all there is to do. Nice and sweet. So there's no need to touch pen or paper, and there's no need to read any of this stuff. Just please understand the process. This is a nice one. I love it. Looking at negative sign first, that's flipping. This is stretching by a factor of 2. 2, again, remember, inside of the function, everything has the opposite meaning. So now 2 instead of a stretch means compression, and pi over 4, negative means it's to the right. And plus 1, now again, it's outside of the function, so it's a literal interpretation. So plus 1 means it goes up by 1. So first thing we're going to do is we're going to flip it. Now we're going to stretch it. Now we're going to compress it horizontally. By the way, we stretched it vertically by a factor of 2. Now we're going to compress it horizontally by a factor of 2. So we're going to drag this over here. We're going to shift it by pi over 4 units to the right. And we're going to shift it 1 unit up. And that's all there is. Just like that. I don't even want to read any of this. You don't need to figure out the period. It's just linear transformations. Trust me, it's much easier than some people make it look like. And same thing. Negative means we're going to flip it. 3 means we're going to stretch it by a factor of 3. Plus pi over 4 means we're going to shift it left by pi over 4. Minus 1 means we're going to shift it down by 1. And there is no horizontal stretch or compression, so we're not going to do it. That's it. It's that easy. Ooh, this one has it all. So again, negative means we flip it. 1/2 means, again, it's inside of the function, so it means we're going to stretch it by a factor of 2. So this now from 2 pi is going to go to 4 pi. Plus pi over 4 means we're going to go left pi over 4. And minus 1 means we're going to go down minus 1. That's it. Much easier than even what was available 5 years ago or 20 years ago. So enjoy. Same thing. Too many twos for my liking, but easy. Times 2, compression by a factor of 2 horizontally, and pi over 2 units to the right. Done. I love doing this problem, so I hope there is more. And we're out of problems. All right, let's see, is there anything else? Well, let's just continue with this homework, I guess, or with all of this homework. So here we're solving trigonometric equations. And trigonometric equations, the way we solve them, it's pretty much everything we talked about before about solving equations applies to trigonometric equations. That means you can still use your Desmos and Wolfram alpha in the same exact way. Let's try. Give all the solutions. However, it could be, well, yeah, we should be fine. Let's try. So we have two sides of the equation. So instead of theta, I'm going to be using x, right? So the left-hand side is 2 contention x minus 2. And the right-hand side is negative 2 plus 2 square root of 3 divided by 3. And we see that this equation has infinitely many solutions. So if there are multiple solutions, separate them with a comma. However, we're not looking for all of the solutions. We're only looking for solutions that satisfy this particular domain. And now we see that in this particular domain, there are only 2 such solutions. And actually from Desmos, we can tell that the answer is pi over 3. I don't know if it's going to like that pi, but let's see if it doesn't like it, we'll fix it. Pi over 3 and 4 pi over 3. Solving the equation means finding the x values for which the equation is a true statement. So again, we're only looking at the x values here as the solution of the equation. Let's see if it likes it. It didn't like my pi, so I guess we'll just have to retype it. Oh, there it is. Let's try it again. Now, if you were to type this equation in Wolfram Alpha, you may not like what you see as the answer. Let's try. Because, no really a reason, but let's see. It does give you the answer in the general form. So it says like, hey, this is your solution. Now it says, this is the solution for all values of n. This is how, like, if I had to solve it, like, I would probably solve it the same way, and then I would just plug in values of n, like, which will make this, the output of this formula satisfy the original domain constraint. So we would plug in n equals 0, so this is where your pi over 3 comes in. Then you will plug in n equals 1. This is where your 4 pi over 3, and then plugging in n equals 2 or n equals negative 1 will put this outside of the original restrictions. So so this is how you know that there are only 2 solutions. Looking at the output of the Wolfram Alpha solution. However, the fact that there are 2 solutions, it's quite obvious from looking at the Desmos graph. So for this particular one, for this particular assignment, Desmos is a great, great tool. And doing it by hand, definitely. Nobody's got time for that. Let's do... But please don't misunderstand me. We will be doing a lot of things by hand when we get to the actual calculus, okay? So enjoy while you can still use technology for every problem. That's what the purpose of this homework is for, not to stress you out, but to give you the last opportunity to enjoy algebra. Same thing, left-hand side, right-hand side, same domain. Where are the graphs? Oh, there they are. We have 4 solutions, which is pretty cool actually. Pi 2, 4, 5, right? So we got pi over 3, pi, 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 pi. So we got pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Interesting. What am I missing? Pi over 3, 6 cosecant squared theta plus 6 That's really interesting. Oh boy. Silly typo. I almost went down some real spiral here to some rabbit hole in my mind, but yeah, this should do. Alright. No worries. Oh, what a little baby trigonometric equation. Let's just solve it. So it's nice and cute little, so little tiny one. Oh, this is a sneaky one. So remember, we're looking for the answers to be in this domain. So while it does appear there are 3 solutions, the one on the right actually does not fit the restricted domain. So there are still only 2 answers, 0 and pi. Ooh, little baby equation can bite, huh? So pay attention. And if you're not doing it with technology, like by graphing, like you really have to be aware of all these little things when you solving these equations analytically. Another one. We have again 4 solutions. Pi over 3, 2 pi over 3. Oh, it doesn't look like I should have just copy and pasted the other one. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And we are done with solving equations. Wasn't it fun? I think it was. So let's go to the next homework assignment. And trigonometric identities. Now, trigonometric identities, it's a different type of animal. Depending on the question, you may or you may not be able to use technology to do whatever they're asking you to do. If they're asking you to derive one, that requires an analytical approach. However, if they ask you to verify one, we can verify identities with technology. And if there is such a problem, I will be more than happy to show you how. So let's see what Newton has for us. And great. So write your answer as the product and quotients of sine and cosine theta. Right. So here they do ask you, you kind of have to grab a piece of paper for this one. I just don't have paper. So let me just copy this real quick and hopefully I can try not to use paper, I guess. But sorry if it's gonna take me a while. All right. This is what we have, right? So this is, and I think Desmos is freaking out when it sees a lot of this White actually freaking out. Doesn't like all this. What doesn't it like? I think it doesn't like secant. Doesn't like secants to be squared. Hold on, let me see. Yeah, I have no clue what it doesn't like, but it's weird. Anyway, so to do this, we are going to answer this question. We're going to remind ourselves a few identities, and again, all the identities that you need to know for this class are in this video right here. That I said I would really, really, really appreciate you watching. And the identities that we're looking for here, for example, some of them can be found right over here. Let's go back just a little and a little forward. There you go. And here you can see that secant squared x minus 1, it's actually tangent squared x. So that's what I'm going to do next. I'm literally going to go step at a time. So instead of this, I'm going to write tangent squared x because that's what secant squared minus 1 is. 1 minus cosine squared x, it's somewhere here. Right here, right? 1 minus cosine squared x, it's sine squared x. So instead of this, I'm going to write sine squared x. Now, the next thing I'm going to do is I'm going to interpret the cosecant and tangent. So for that, we're going to go a step back. Cosecant x is actually, where is my cosecant? Cosecant is right here. So cosecant is reciprocal of sine. So instead of cosecant, I'm going to write 1 over sine x. And instead of tangent x, I'm going to write sine x over cosine x. So that's the first step, right? I guess as we doing it, we might as well, instead of tangent squared x, write sine squared x over cosine squared x. And now we're going to simplify it. We're going to carefully rewrite everything, right? So what's in the denominator of the numerator has to go to the denominator, and what's in the denominator of the denominator has to go to the numerator. Those are just the simple properties of basic operations or working with fractions. And once you write it like this, you can see that this can definitely be simplified, right? So we can cross out this sine squared, we can cross out this sine squared, we can cross out this cosine, and we can cross out this cosine, and these two sines can be combined into sine squared, and we are done. So let's go back and see if can answer the question. Sine squared theta, where's my theta? How do I put theta here? Oh, trigonometry. Oh, lifesaver. Sine squared theta times cosine theta. That would be my answer. And we got it right. Now, how can we verify an identity? Like, let's say before I enter this answer, how do I know if I got the right answer? Well, the easiest way is to define a function. It's just we have to figure out what's wrong with all this. What Desmos doesn't like about this. Like, we just need to make Desmos happy. What doesn't it like? Not that. See, it's like, oh, now it likes it. Okay, gotcha. All right, so this is the original identity. It can be represented by a function, and the identity that the expression that we got at the end can also be expressed as a function. And if they are, if there is truly an identity there, then the two graphs have to match. And what do you know here? Look, they actually match. So this is how we know that these two are equivalent, and therefore we have an identity. This was just time consuming. Here's another trigonometric question. Evaluate cosine by rewriting one. This one should be easy, right? So cosine of 105 degrees can be written as cosine of 60 plus 45. And we do have an identity for that right over here. Cosine of the sum is cosine of the first one times cosine of the second one minus sine of the first one times sine of the second one. Let me bring it over here. And now we just need to evaluate each one of them. Cosine of 60 degrees is 1/2. Cosine of 42 degrees is square root of 2 over 2. Sine of 60 is root 3 over 2. And sine of 45 is square root of 2 over 2. And now we can simplify this. So we have square root of 2 over 4. And here we have square root of 6 over 4. And that's the final answer. So cosine of 105 degrees is equal to square root of 2 over 4 minus square root of 6 over 4. And we got it. This one's going to be long, so you better not make any mistakes here. Oh, I don't know if you noticed, but they had a different solution for, maybe you want to rewind here, different solution, but it doesn't matter how you solve it, you will get the same answer. Another problem similar to the first one, we have sine of 2 theta, tangent to the power of 4 of theta, and this is, let's just call it our function, and here we have times, and again, that one doesn't like this 4, so I'm just going to put the 4 on the outside here, right? So this is my original expression. Now to simplify it, we're going to use the double angle identity. Double angle identity is right here. So instead of sine of 2x, I'm going to write sine x cosine x. And instead of tangent x, I'm going to write what tangent x stands for. That is sine x over cosine x. And we can distribute this power of 4 to the numerator and to the denominator. And now it's just simplifying, right? So this cosine cancels one of the cosines in the denominator, but this sine contributes and adds another power in the numerator. So this is my answer. Now we just need to figure out what this doesn't like, and of course it's going to be the power. And as soon as we fix that, we're going to be able to see that that's the right identity. You see how the graphs are exactly the same? That means we do have the correct expression. So 2 sine to the power of 5 to the power of 5 theta divided by cosine to the power of 3 theta. I wish it was moving a little faster. They're trying to help us here, right? They're like, hey, here's the template for the answer. Don't mess this up. So let's just speed up a little here, right? So I'm just going to apply. Cosecant is the reciprocal of sine. So this is what we have instead of cosecant. Secant is reciprocal of cosine. This is what we got. So this is my whole numerator, right? My denominator now cotangent. Cotangent is the ratio of cosine over sine. And now we just have to rearrange things, right? So everything from the denominator of the numerator goes into the denominator. Everything from the denominator of the denominator goes into the numerator. And now combining these cosines, we get what? 8 of them altogether. And subtracting these signs, these 3 signs from the top, we get 2 of them. And now, since they don't want us to have any denominators, we can just rewrite it with a power -8. That's the answer. So sine is raised to the power 2, cosine is raised to the power -8. Ooh, we're almost there. Look, we're almost there. 95%. This one, this is this one actually doesn't belong here. But I think it should be in the next homework. But to answer this one, I definitely need a piece of paper. So let me see if I can find one real quick. Find a piece of paper, but I did find this PowerPoint, blank PowerPoint, so I'm going to write with my mouse here, so please forgive me. But this problem is pretty much, well, first we have to understand that computing sine of 2 theta, it's the same as computing 2 times sine theta times cosine theta. That's the first thing to understand. Now, cosine of theta is given to us and it's said to be equal to -3/4. So the question is now, what is the sine of theta when cosine of theta is equal to -3/4? And the answer to that question is actually right in this lecture. So this chart helps you to find all the trig functions when any one of them is given. So for example, if cosine is given, you can find sine, then cosecant, cotangent, tangent, secant, and so on. So if you know cosine, you should know how to find sine. Now, there are multiple ways of doing this. The first way is to just use this trigonometric identity. So for example, sine of x, or in this case, sine of theta, is simply going to be equal to plus or minus square root of 1 minus cosine squared of theta. And why is it plus or minus? Because technically it's sine squared plus cosine squared is equal to 1. So when you're isolating the sine, you have to put plus or minus. So continuing with these computations, plugging everything in. And what do we get? 3/4 squared is 9/16. So let me just continue writing this. One minus 9/16 is what? 7/16. and square root of 7/16 is square root of 7 over 4. And the question is it plus or minus? And this is where we're going to use the knowledge of the quadrant. So in third quadrant, last time I checked, in third quadrant, cosine is negative and sine is negative. So because of that, we're going to use the negative. And now we're ready to find the sine of 2 theta because we know what this is equal to. So sine of 2 theta is equal to 2 times negative square root of 7 over 4 times negative 3 over 4. So the final answer will be 3 square root of 7 over 8. Now, alternatively, we can find sine from analyzing the cosine of theta being equal to negative 3/4. What does that mean? That means, because cosine is the adjacent over the hypotenuse, that means there is a triangle in a third quadrant, right? So the triangle is going to look like this. And the adjacent side, this is your negative 3. And the hypotenuse will be equal to 4. So by Pythagorean theorem, this side will be equal to square root of 16 minus 9, which is square root of 7. And looking at this triangle, we again conclude that sine of theta is equal to the opposite over the hypotenuse, and it's going to be square root of, because again, it's a third quadrant and it's below, so it's negative, right? So it's going to be negative square root of 7 over 4. Very easy to make mistake here, so you just have to be careful. And then when you put it back in, you still get the same exact answer. So this is our answer. So sine of 2 theta is equal to 3 square root, doesn't like my square roots, square root of 7 divided by 8. And we are hopefully done. Yay! And let's see what else is there. I think that completes this lesson. We just finished this one. And let me stop right here.